Hello guys, welcome to Pepcoding. In this video, we are going to discuss a question named first index and last index. So let's understand the question. So for that, we have to go to the whiteboard. Let's go here. So the question statement is, we will be given a sorted array and will be given a value, just say 33. As we can say, there is a duplicate value of 33, right? So what we have to do here, we have to print two things. First is first index and last index of what? 33. As you can see, 33 has appeared here more than one time, right? So first time 33 appeared at fifth index, so for first index we are going to print 5, and for last index 9, so we will print 9 for the last index. So this is the question statement. Let's see how we are going to do this. So we are going to find first index, and then last index, and we are going to use here binary search algorithm. So for that, we will be initializing two variable low and high with 0 and last index. Okay, so the first thing that I'm going to do here is I'm going to initialize a variable fi with -1, and we have low as 0 and high as 14, right? And with the help of low high, we are again going to find mid, that is 0 plus 14 by 2, that is 7, as we are going to use binary search algorithm. So we'll come here in the mid index and we will check. What we will check? We will check that whether mid index is 33 or not. If it is, as we can see that our mid index is already 33, in that case what I'm going to do, I'm going to update my first index by 7, as I know that this could be our first index. That's why I have updated fi by 7, so that if I didn't find any 33 in the left area, I will just print fi as a 7. So for that, what I have done, I have updated fi as 7. Okay, now see, I will say it is good that you have find 33, but see, the fact is you want the first index. So if there exists 33 in the left area, this is the left area, that's supposed to be your answer. So what you should do, you should not stop here. If you find 33, it is good, but you should not stop here. You should search in the left area. You should continue searching in the left area. So that's what I'm going to do. I'm going to update high by mid -1, so that I could continue searching in left area. Now again, in the next iteration, I will find mid, which is going to be 0 plus 6 by 2, that is 3. So I will come in the third index, that is our mid index. We will check that in the third index is 19, which is not 33. So what I will do, I will update low by mid +1. That's what we do in the mid binary search, right? So I will update low by mid +1, and we will search in the right area, in this area actually. Okay, now again we will find mid, which is 4 plus 6 by 2, that is 5. So we will come here. This is our mid, this is our mid. So we will check here. So what's here? Again here we have gotten 33. So as I said, whenever we will find 33 in the left area, we are going to update fi. So update fi as 5. So as I have done more iteration, fi gets updated and it will get more accurate value. So now I have 5 as a fi. Now what I will do, I will stop here or not? I will not. As I said, I will not stop. It is good you have gotten the 33 and you have updated the fi, but you should not stop here. You should search in the left area. Why left area? Because if you find 33 in the left area, that's supposed to be your fi. So what I will do, I will update hi by mid minus 1 so that I could continue searching in left area. Now low and hi are in the same place, so mid is also going to be here only. Okay, now I will check here. It is 21. So what I should do, I should update low as a mid plus 1. Now low is greater than high. So what I should do, I should stop searching and see in fi I have the correct value of first index of 33, which is supposed to be 5, and I am having 5. So this is how I will find first index, right? Now let's see how we can find last index. Okay, last index. So again here we are going to use binary search. First initialize li with -1. Now initialize low with starting index, high with the last index. This is your low, this is your high. Good. Now find mid with the help of low and high. That is going to be 7. So you will come here and check that 7th index is 33 or not. If it is, what you should do, you should update li so that in future if you didn't find, that could be your answer. And of course in the next iteration it will get more accurate. Now tell me one thing, it is good you have find 33, but where should you, what you should do next? I will say you should continue searching in right area. Why right area this time? Because if there exists 33 in the right area, that's supposed to be your value because you want the last index, right? So what I will do, I will update my low by mid plus 1 and say him, bro, search in the right area, because if there exists, that's supposed to be your value, your answer, right? Okay, now in the next iteration again I'm going to find mid, which is 8 plus 14 by 2, that is 22, that is 11. Good, come here, here is mid, check what's in the mid. It is 57. Now tell me what I should do. It is 57, it is greater than 33, right? So whenever I get the greater value, what I do, I update hi as mid minus 1 and I'll continue the iterations, right? So again we will find mid, how 8 plus 10 by 2, that is 9. So I will come here and check what's in the 9th index. So in the 9th index we are having 33. So again we have found 33 now. So what I will do, I will update li by 9, and as you can see our li is getting updated with more accurate value, right? Okay, again we will do the next iteration. What I'm saying here, it is good you have find 33, but where you should continue searching, you should continue searching in the right area. For that what you need to do, you need to update low by mid plus 1. What I am doing now, again high and low are in the same place, so mid is also going to the same place. Now check mid, that is 42. What you should do then, update high by mid minus 1. Now low is greater than high, so this condition only happens when you should. Okay, see now you have 9, which is the correct value of li in the li variable. So let's start coding. Okay, so let me do this in. Okay. So what I'm going to do here, input has been taken in list and we have to search for data, right? Okay, so what I will do here, I will define two functions. First one is first. What is he going to do? He going to give me the first index, right? I will take that. And second is last function, and I will give him last and data. He is going to give him me a last index, and I will finally print that. Print fi, print li. All set. Now let's see how we can find first index. Okay, as I said, first I will declare of fi variable with -1 and low with first index, high with last index, as we do in the binary search. -1. Okay, a start iteration till low is less than equals to high. Okay, first thing you will find mid. How? You will add low plus high and divide that by 2, and you will check if your mid is equals to data. What you should do here, you should update fi with mid. So fi will be updated by mid index in case you find the data, right? And what you should do after that, you should continue. You should not stop here. You should continue searching in left area because you want the first index, right? So for that you should continue check for that particular element in the left area. And how we can do that? We can update high by mid -1. Okay, next possible thing that could possible is your mid data is less than data. In that case, it's very obvious. We will search in the right area. For that, we will update low by mid +1. And the last thing is when mid data is greater. In that case, we are going to update high by what? Mid -1. So all set. After completing all the iterations, you will having first index in fi. So you will return that. Well done. Now we will do for the last index. So write it first, last, list, and data. Okay, again you will declare last index variable, describe that with -1, low with 0, and high with last index. Length of list -1. Till when low is less than equals to high. You will find mid, low plus high -1. If what I will check here, if mid value is equals to data or not. If it is, what I will do, I will update li with mid index. And should I stop here? No, I should not. I should continue searching in right area because we want last index, right? So if there exists a value in the right area, we should update that with the with the right value. And for that we are going to update low by mid +1. Next thing that could possible is your mid data is smaller than data, right? That case, what you do, you update low by mid plus 1. And the last thing that could possible is your mid data is greater. For that, you are going to update high by mid minus 1. So all set. After completing this iteration, you will having last index in your li. So just return that. All set. Let's all good. Fine. Let's run this. Check it for any compilation error if there is. Yes, it is. Let me check. Okay, let me check last function. Okay. Here I have for mid, we have to divide that by 2 now. So I'm done from there. So let's run this. Yeah, it is accepting. Let's try submitting this. Yeah, it is running for all the test case. So this is how we are going to find first index and last index for a particular value in an. Hope you like the video. If you like the video, please like, share and subscribe to our channel. Thank you.